Session 4.4, Evaluating the Linear Model. For these sessions, we're going to talk about the cautionary regarding the regressions. First, don't use linear models to describe nonlinear associations. Always look at the scatter plot first. For the chapter 4, we only focus on the linear association. And regression models are only useful for the linear association if the association is not linear. A regression model can be misleading and deceiving. Correlation is not causation. An association between two variables is not sufficient evidence to conclude that a cause and effect relationship exists between the variables. Even though we find the correlation is really strong or a good fitting regression line, this is not evidence of a cause and effect relationship. You only can say the two variables are associated to each other, but you can't draw the conclusion saying one thing caused another things to happen. Beware of outliers that can have a big effect of R. Always check the scatter plot for outlier first. You should always check the scatter plot first before performing a regression analysis. You have to make sure there's no outliers. Don't extrapolate. Don't make predictions beyond the range of the data because we are not sure that the linear trend will continue beyond the range of the data. Our prediction may be wrong if outside the range of observed X values. Look at this example. In a previous example, we found there was a strong linear relationship between the height and the weight in women. And the regression equation is. So we do have the data here, and then we have the regression equation. Y equal to negative 442.82 plus 9.03x. What weight does this equation predict for a woman who is 36 inch tall? Okay, 36. So your x equal to 36, what is your y equal to? So if we just plug into the regression equation, what happened? We're gonna find this woman is gonna be negative 117.8 pounds. Is it possible? No, right? Because when you plug in the x equal to 36, and 36 is gonna be outside the range of the values. 36 is somewhere like here. So we can't use the regression equation to predict the values. The x, it has to be within this range. Coefficient of determination, the R squared. Remember we find the correlation coefficient in the previous sessions, the R, right? The coefficient of determination, it just means you want to find the square of the R. And remember the R is always in between negative 1 to 1. So when you take square of the R square will be in the range from 0 to 1. And usually we will convert to a percentage. So the R square is always in between 0% to 100%. What is the meaning of 100% of the coefficient of determination? It means the relationship is perfectly linear and the regression line perfectly predicts the observation. Okay? And a value of 0% means there is no linear relationship and the regression line does a very poor job. The larger R square, the smaller the amount of variation or scatter about the regression line. And measure how much variation in the response variable is explained by the explanatory variable. Okay, look at this example. For the data on car age and predict value, R is equal to negative 0.778. Compute and interpret R square. Okay, I want you guys first find the R square and then interpret the coefficient of determination. So use your calculator. You should get 0.605. And we usually convert it to the percentage. So that would be 60.5%. Okay, now we interpret the R square. The car age explains about 60.5% of the variation in car value. That's it.